Well, I hope everybody did a good job with the five number summary and finding the different quartiles and things like that. So again, if you did have trouble, definitely let me know and stuff. So now what we want to do is actually look at a graphical version of that same exact data. So what we're going to do is we're going to make what's called a box plot in this case. So if you look at the picture here, we've got an example of what a box plot looks like. So notice it's got our min value on the left, it's got our max value on the right, and so those lines are what are called the whiskers of the plot. So sometimes you'll see this as a box and whiskers plot's what it's called. And then the box always consists of the the quartiles, so Q1, Q2, and Q3 are the median. And so notice, this thing doesn't have to be like kind of symmetric or in the middle because data can be all over the place. So that's one of the nice things about these box plots. It actually gives you a kind of an idea of like whether the data is kind of moved more to the right, is it moved more to the left, is the box really really big. We'll actually be able to learn a lot of information from these different pieces and stuff like that. So now the one thing that's missing on here is there's no X scale on the bottom. So we will want to actually put an X scale on the bottom because if we just kind of draw the box plot with no scale, we may be tending to make it symmetric when it really isn't symmetric. So it's important that we actually kind of label the bottom to make sure that our graph actually looks like what we want it to look like. All right, so let me show you an example of a box plot here. So in this case, we've got 40 books that are on a bookshelf, and what we want to do is construct a box plot. So before we can do anything, the first thing we need to do is actually do the five number summary. So before you can actually make a box plot, you have to have a five number summary. So find Now, the last five number summary that we did it by hand, only had like 20 data values. So it wasn't that big of a deal. So one with 40, I mean, again, you could do it. It's not that hard. But I mean, this one would definitely be a good one for you to use the calculator on. So I won't bore you with walking through the calculator steps again. So I went ahead and did it earlier. And so I saw that the min was 136, Q1 was 237, the median was 322, Q3 was 395, whoops, and the max was 512. So in this case, what I want to do first is actually kind of make an axis that's going to capture the min and the max in this case. So think of this like an x-axis. So I'm going to draw a little line down along the bottom first. And so I've got to make sure I include 136, but I also need to make sure I include 512 in my axis. So you can kind of use whatever scale you want, it doesn't matter. So I might go make it as big as possible and try to spread it out by like 100s or something like that. So let's get 100, 200, 300. And obviously, if you were using graph paper or if you were using a ruler and stuff like that and trying to spread it out, like that would probably be better. So in this case, what I'm going to do is I'm going to actually draw the whiskers first and try to approximate them as much as I can. So the graph actually lives far above the line. So like in this case, my 136, I'm going to approximate that it lives right around that area. And my 512 is going to be just a little bit to the right of 500. And so again, if we had graph paper or we were able to write this out with a bigger scale, it would definitely look better, but we'll still get the gist of what's going on. So now I want to work on drawing my box part. So in this case, 237 is going to kind of be in that area. My median is about 322, so it's going to run in that area. And then Q3 is 395, so it's almost 400 exactly. So let me go ahead and put the box around my Q1, Q2, and Q3. So again, there's my Q1, my Q2, my Q3. Here's my min. Here's my max. And then now just draw a line from the outside lines to the middle of the rectangle. So in this case, either my scale is actually pretty good or off terribly, or this data looks like it's pretty symmetric. So if you look, it looks like it's kind of in the middle. It looks like there's as much to the in between the min and Q1 as it is between the Q3 and the max. And the median kind of looks like it's in the middle between Q1 and Q3. So it looks a lot different than the one above, where you can see the median was a lot closer to Q1 than it was Q3. And there was just a little bit of data between Q3 and the max compared to Q1 and the min. So that happens. So this looks like a nice symmetric graph. So I'm saying it looks pretty good. So, all right, any questions or anything about that? All right, perfect. So let's look at another example here real quick. So this one, what we're going to do is actually use two different sets of data to kind of compare what they look like by using our box plot in this case. So at the top, we had test scores for a statistics class that was held during the day. And then at the bottom, we have test scores for a statistics class that was held during the evening. And so you can see we've already done the work. So we've already got our 5-number summary. So again, if we didn't have that and all we had was the data, the first thing we'd have to do is find our 5-number summary and then use that 5-number summary to plot our box plot. So now I want to do kind of the same thing I did before. I want to actually break this up into some kind of a scale so that I want to make sure the mins and the maxes of all these things occur. So in this case, my min is 25. My biggest max is at the day class of 99. So I think I'm just going to go ahead and make 25 the smallest and then just go the whole way up to 100 in this case. So I'm going to go 25 way over here and then 100 way over there. And then let's see, so what do I go by? So I'll have a 50 here and a 75 there. And I could break it up more if I wanted to. I mean, again, if you have graph paper or if you're using a ruler and trying to be more precise, it would be a little bit nicer. But hopefully this will give us a good idea. And so what I'm going to do is I'm going to plot the day students on top. So I'm going to put them up here. And I'm going to put the evening students down below. So that way we can kind of compare the two different box plots together. So in this case, our day students are the ones on the left. So they had a min of 32. So I'm going to put that in first. So it's going to be somewhere in this area. And a max of 99. So it's going to be the whole way over on the right, almost at the 100. And so they had a Q1 of 56. So that's going to be about there. A median of 74.5, so it's going to be right about there, and a Q3 of about 82.5. So again, let's draw our rectangles, and then our little line out to our whiskers. So again, we've got our min, Q1, Q2, Q3, and max. And so we can see this guy definitely doesn't look very symmetric. I mean, look at the major gap between Q1 and Q2. So again, even though there's a huge difference between those two, still only 25% of the data lives between those two scores. It just so happens that it's just a big spread. The scores must not be that close together in that situation. So now let's look at the evening class. So we had the min of 25. Max of 98, so it's going to be just a little bit inside of the max above. So Q1 is 77, so it's like way up here. The median of 82, so it's going to be a little bit of the inside of where their Q3 was. And then 89.5. So again, that gives us this rectangle. And then this huge, huge gap between the minimum score and Q1 in this case. I mean, almost strangely out of place. So again, when we actually look at this data, which class do you think you'd rather be in? It looks like the evening class to me, so because look how far to the right all those Q1, Q2, Q3. So like in this case, the median of the above class is actually, what is it? So it's almost the same. Actually, the median of the above class is actually smaller than the Q1. So in this case, 50% of the students scored below 74.5, where in this class, 25% scored below 77. So in this class, the bottom class, 82% scored below 50%, or 50% had a score of less than 82. So the Q3 of the other class was actually 82.5. So it looks like the evening class did a little bit better, and you can see that kind of the way the data is all shifted to the right in this case, and there's not as much gap. So there's 25 we're actually going to talk about in the next section. So that's probably something weird happened. Who knows? Maybe the person had missed a bunch of classes or something like that. Maybe they hadn't had a chance to study. But it seems to be what's called like an outlier. It seems to be a data point that just didn't really fit in with the rest of the data, because most of these scores are in the 70s, 80s, stuff like that. And then there's this random 25 that just kind of came out of nowhere. So that's actually what we want to talk about next. So outliers are just unusual data points. So like sometimes they could be a mistake in recording, or so it could be just some weird instance. So who knows what happened with that one student. Again, maybe that was their, maybe they'd missed a bunch of classes, showed up and it was the test day and the teacher made them take the test even though they weren't prepared or something. So things like that do happen. There can be these datas that kind of mess up the rest of the data. So what we're going to do is look at another way that you could actually plot this box plot, the same one, but represent the outliers a different way. So before we talk about that, what we want to do is talk about what's called the interquartile range. And so it's the range between Q1 and Q3. So it's basically the difference between the box that we see in our box plot. So we just take Q1 minus Q3 to figure out what that interquartile range is. And the outlier, if we want to actually try to figure out if there's data that's possible outliers in the list, then what we want to do is use the following rule. So we multiply the interquartile range, which we're going to abbreviate as IQR, just so we don't have to keep writing it over and over and over, by 1.5. And then what you're going to do is subtract that value from Q1, and at the same time kind of add that value to Q1. So what we're going to get is Q1 minus 1.5 times the IQR, and then we're going to take Q3 plus 1.5 times IQR. And whatever that value is, any data points that are below the Q1 value that we just calculated would be considered an outlier, and any data that lives above that calculated Q3 value would be considered an outlier also. So let's actually do one with the example above. So again, this is the exact same data that we had above for the physics class. So 25, 77, 82, 89. So this is the evening class, exact same data. So if we want to find this interquartile range, we're going to do 89.5 minus 77, which gives us, was it 12.5 it looks like? Yep, 12.5. And now we want to find if there are any outliers in this case. So again, what we're going to do is we're going to take that interquartile range, multiply it by 1.5. And so I forgot to do this ahead of time, so we go to the calculator real quick. 1.5 times 12.5 gives us 18.75. So what we want to do is take this Q1 minus 18.75 gives us 58.25. And then for Q3, we want to take our 89.5 and add 18.75. Oops. So 89.5 plus 18.75, 108.25. And so what we're looking for are numbers that are less than this number or more than this number. Well, the good thing is, if we remember, our max was 98, and since this is a test score, like the only way someone would have more than 108 is if there was a massive amount of extra credit. And so it appears for this test, even if there was a massive amount of extra credit, people didn't actually earn it. So there's no outliers above to the right-hand side. But are there any outliers to the left-hand side? Well, we definitely have at least one, because we know the min is 25, which is well less than 58.25. So we should check and see if there's any other outliers on the list. And lo and behold, we've also got a 45, which is also less than the 58.25. So in this case, our two outliers are going to be the 25 and the 45. So what we want to do is actually now make a new box plot, kind of assuming that those outliers aren't really there. So I am going to note that they're there by using a point. But what I'm going to do is actually find a new minimum. So let's actually consider, if those data points weren't there, what was the actual minimum, not counting those. So it looks like in this case, the next smallest value after the 45 would have been a 65. So in this case, I'm going to actually plug that 65 in as the new min. So that's going to be my whiskers. But I still want to actually account for the 25 and the 45 in my box plot. I'm just going to do it a different way. So when I do my graph, I'm still going to do like I did before, go from 25 out to 100, and then 50, 75. And so in this case, instead of doing, like, I'm going to save the 25 and the 45 for last. I'm going to go ahead and calculate the new 5-number summary that we've got here. So 65 is going to look somewhere in this area. So that's going to be my 65, or my new min. And then my max is the same. So everything else is still the same. So my max is still out there. My Q1 was the 77, so it's going to go there. My median was like the 82, and my Q3 was like the 89.5, so it goes like there. So again, draw my little line from there to there. So this is really, if those two outliers weren't there, that's what our box plot should have actually looked like, and that's more representative of all the other data that's there. So if we actually kind of scroll up and look, doesn't that look like a lot nicer box plot than the one we have here with this huge line that runs down the left-hand side? When in reality, so it's telling us that 25% of the scores live there, but 2 of those are really making it look worse, because they're really dragging that score down to the left. Where this one just looks a little bit nicer. So how do I account for that 25 and 45? Well, I don't want to forget that they're there. So what I do is I just put a dot to represent. And you put a dot for each one of them. So what it shows me is that this is really more appropriate for what my box plot should look like, but that I did have a few test scores that were out of the ordinary, and here they are on the graph, just with little dots in this case. So, all right, so there's a couple for you guys to practice. So again, these I made you find the 5-number summary just for practice. So again, use the calculator, use the Google Sheets, whatever you want to do. Find the interquartile range, find the outliers, construct the box plot. So this data should look familiar. This is data we've actually been using in the past, so I've been trying to keep the data similar for you guys. If you have any questions, I'll be around all day. Otherwise, just let me know, and good luck.